This is No Frills ASMR. I was looking again at the Atlas of the World, and I saw the Milky Way Galaxy in here. And so I thought today we could talk about the Milky Way. Are we part of it? Who discovered it? Questions we need answered. So I thought we will flip to it here. This book's too big to really be in view, but that's okay. I didn't feel like reorganizing my camera all the way. So this is Space, the Final Frontier. These are the voyages of the USS Enterprise. Does anybody remember that? It's from the 1970s Star Trek TV show. Anyway, so I thought we could take a look at, in particular, here's the moon, our Earth's companion in space, the red planet. And then here is our solar system. The sun's in the center. Oh, by the way, I think in the last video, I can't remember if somebody said this in the comments or if I looked it up later. But it was probably somebody in the comments because everybody's so kind and helpful in the comments. But they said to memorize, I was saying there must be a mnemonic device for memorizing the order of the planets. And apparently there is. And it is my very excellent mom, that's me, served, my very excellent mom served us noodles. Now, the one problem with this device as a memorization is you have two M's. But just know that we have the sun, and then the planets are going out like this from the sun. And the first one you just have to memorize is Mercury. And then very, is Venus. And then Earth. And then Mars is the second. S would be Saturn. This would be bad if I couldn't think of one. And then U is Uranus. We used to call it Uranus. And N is Neptune. So this is the order they go out from the sun. And so you can use that device. My very excellent mom served us noodles for Mercury, Venus, Earth, Mars, Saturn. And of course, like Earth has a moon, and I think Mars, then they have two small moons. I don't know. We're not talking about that today. But so that's all part of our solar system. And our solar system are the planets that revolve around our sun. All right. That we're not talking about so much right now as this, guys, this Earth's galactic home, the Milky Way. I think I have so much glare here. I'm going to set this up on something. Let me think. Hold on. Maybe it'll work on this book I have here. A book about birds because I'm a bird nerd. That didn't help us. Yeah, well, whatever. You guys can see it enough, I think. All right, so this is the Milky Way. And right here, hold on, where's my, I'll just use this. Right here, this teeny tiny little spot that you can barely see, that's our solar system. And all these other little dots are other solar systems, and all of us are just swirling around the galactic center here, which right in the center of it is a black And if you haven't seen the Disney movie, The Black Hole, don't see it. It's terrible. It's awful. Okay. So I think it's like so amazing that like our little solar system is right here and all these other solar systems are moving around here. And then if you want to get even more crazy, this is our galaxy. I think I've talked about this before in a space video, but I can't help getting over it. But then there's like all of these in this picture. Let's say this is deep space. Every one of these bright spots is another galaxy with that many more solar systems within the galaxy. Billions and billions. It's really something. All right, so I took a couple of notes because you know I'm not good at numbers so much. So I had to like remember some of this. But basically, from our sun to the Earth, which by the way is only, the third planet out from the sun, is 93 million miles. But they don't really categorize it in miles, they categorize it in light years. And a light year is the amount of time it takes light to travel, or the amount of miles light can travel in a year is a light year. And light can travel about 6 trillion miles in a year. So when they say that our galaxy, like for example, okay, because this stuff, what's the word I'm using? Confuses my brain. But so what did I say? A light year is 6 trillion miles. And our galaxy, from like one side to the other side, is 100,000 light years across. Let that sink in for a minute. So our galaxy is 100,000 light years across, and each light year is 6 trillion miles. What? It takes the light of the sun 8.3 minutes to travel to the Earth. So when you get the light of the sun on you, that's 8.3 minutes old. So we're relatively close to the sun compared to like how big our galaxy is, right? That's crazy. I think I got that right. The distance from our sun to basically the next star or the next sun into another, solar system? Is that right? Yeah. Because another sun would be... So the distance from our sun to the next one is 4.3 light years. So that's how far and how long it is. And in the last video, I made some comment that my brother had told me that when you see light from a star, by the time you see it, it's already burnt out. But somebody in the comments said that is, that used to be a thought, but that's been kind of proven wrong. That now they know some of those are definitely still burning. All right, so let's go back to the Milky Way because I'm sort of fascinated. So, if you're out in the dark night, you kind of need a sky with not much ambient light, or what do you call that? Like pollution light. But if you're out in the dark, you'll a lot of times see the Milky Way. And it almost looks like just a cloud of light. And you don't see it all over the whole sky. You'll just see it like a line of light. And what it is just billions and billions and billions of stars. You might look this up. I think this. And you can't pinpoint them because they're so far away. So you're just seeing the light of all these stars, almost like this. And it just looks like a cloud of light. And the reason hold on, I got an idea. Okay. All right, hold on. Nope, I'll just set that. Sorry. The reason it looks so like just a line is because the way you're seeing the Milky Way, well, actually, here's kind of an image. It's like a band because we're here and you're looking into it this way and not out of it. So you're seeing like this, like that. So that's why you see it as like a line. Actually, I just thought of something. Oh, shoot, sorry, that was loud. I don't know where to put my, isn't that a pretty little plate? The rose. Hold on, I just thought of an idea. Let me grab this coffee can I was about to use. Because this lid might work. This lid's broken, but I was reading, they said our galaxy, the Milky Way Galaxy is kind of being pulled by two outer forces, and it's kind of does this. It's not flat. It's sort of warped. So I don't know if you can see that when you look up in the sky, or if that's way too, but they said it's kind of like our galaxy isn't a flat disk. It's a warped disk, which I thought was kind of interesting. I have this old coffee can I got to put, random supply things in. And it's vintage, like probably from the late 60s based on that. And I noticed this price tag this morning, $4.49. Doesn't that seem expensive? I feel like I know I bought Maxwell House with a coupon, and it's not good coffee, but for $1.99 for a big thing of it. Anyway, all right. Let me set that down quietly. All right, what else did I want to talk about? The Milky Way, let me think. I know this. The Galactic Center. They actually talk about it here. Let me move this out of the way. Down here, the heart of the Milky Way, the mysterious core of our galaxy, is revealed in greater detail. I guess that's it. Super. Than ever before in this dazzling mosaic of hundreds of thousands of individual images from infrared Spitzer Space Telescope. Spitzer? I don't know. New stars are coalescing in bright regions of yellow and red, while the green haze is gas thrown off from the starburst. So this green haze. That's crazy. Thrown off from starburst. Blue pinpricks throughout the image are the Milky Way's older stars, while what the image can't show is Sagittarius A*, a supermassive black hole whose gravity dominates the Milky Way's core. Whoa, so the black hole is called Sagittarius, and it dominates the Milky Way's core. Guys, I'm a Sagittarius, and I definitely dominate the core. Interesting. I had no idea. Okay, so there's a black hole in the center, and maybe I'm making an assumption here. I'm not sure, but the gravitational pull of that black hole is what keeps this thing swirling. But then at the same time, like I read, there's pull from out here. So that's interesting. And I remember one time my brother telling me, because I told you he's kind of a space guy. I mean, not, he didn't study it. He just studied it on his own. But he was saying a lot of times what they're analyzing and studying isn't actual images from space, but more looking at, they know something happened based on the gravitational pull, so they can tell something else bigger is outside of there because of the way the things are being pulled in the direction of that. So even if they can't see this, they can see the pull. Does that make sense? I think. Somebody can correct me in the comments. I'm wrong. So here they talk about crowded stellar neighborhood. I looked at this earlier, and it's over here. It's this one. This. I'm going to drop my water. It doesn't look like anything, I'll tell you. It's just a teeny tiny little blip. You can't even see it. But there's a little bright spot right here. And they show all these tons of stars. And it says, maximum stars crowd a minimum of space in the Omega Centauri globular cluster. Isn't that weird? Just in that one spot, there's so many stars. Upgrades to the Hubble Space Telescope in 2009 revealed previously unseen color detail, providing clues to the life cycles of cluster's 10 million stars. So they say that different colors show what part of the life cycle that star is at. It's amazing. Let's just see if there's anything here that I didn't already look at. So the Milky Way, Earth's galactic home. Earth's location on the outskirts of the Milky Way means we view the great spiral. See, here we are. Where are we? Wait a minute. Here's Sun. Here's Earth. And we're kind of like on the upper part of this, I guess. This is the Milky Way. And we're like going around here. Where was I? Means we view the great spiral galaxy from the side, and its 200 billion or more stars look like a glowing band across the sky. This is the galactic equator, the plane on which the solar system orbits the center of the Milky Way every, get ready for this, 220 million years. So our solar system, in order to go all the way around and come back, 220 million years. Oh, that's crazy. So when the last time we were at the place we are now, dinosaurs were on the Earth. Is that right? Were they alive 200? I'm going to have to do a dinosaur one. I forget when they died off. If the pace sounds slow, Earth careens on its cosmic merry-go-round at about 917,000 kilometers an hour, or for us United States people, 470,000 miles per hour. I'm sorry, 570,000 miles per hour. If the base sounds Earth careens on the cosmic merry-go-round. Okay, so even though it takes that much, 220 million years, we are moving at 570 miles per hour as we're moving. But that's just how large, how vast it is. It's crazy. The galaxy has 3 distant parts. At the core, right here, is a bright bar-shaped bulge of yellow and red stars. So right here is a bar-shaped bulge of yellow and red stars, okay? From the center, several spiral arms, yep, we see these, sweep out to form a disk that contains younger blue stars, as well as glowing regions of star birth. What makes a star get born? Like, what has to happen? That's another video. Earth resides here, so we're in one of these arms, 25,000 light years from the center, and most of the familiar celestial spectacles, supernova, planetary nebula, starbirth regions, lie relatively nearby. Finally, surrounding the galactic disk is a greater halo of dark matter. That's out here. That's spooky. Why is that spooky? Invisible, but holding most of the galaxy's mass. Wow. I don't even quite know what that means, the galaxy's mass. So all the big stuff's out here. Is that what that's saying? Far beyond the galactic disk, yet drawn by its gravity, lone stars and globular clusters wander the galaxy's halo. Regions of dark matter, unseen but felt through its gravitational effects, extend beyond that. Wow. Guys, I have to look up what some of these things are. Because I read that and part of me goes, yes, I totally understand. And the other part of me is like, I don't even know what you mean by the most mass. I'm not sure. This is Braze Stella Nova. On the 11th day of November, in the evening after sunset, I noticed that a new and unusual star, surpassing the other stars in brilliancy, was shining almost directly above my head. So wrote Danish astronomer Tycho Brahe of the supernova that burned briefly in 1572. There was a supernova more recently than that, but I don't even know what a supernova is. Hold on, I have an idea. Let's get out our book and see if they have supernova in here. I mean, I assume it's a big, I almost called it a B-A-A-S-S, a big star. What? It's not in here. S-U-F-I-M-M. Wait. Oh. Super Bowl. Supernova 490. Makes me happy when it's in here. 490, 85, 89, 490. Super, where are you? I'm having trouble seeing things. Here we go. Supernova, a large star in its death throes. Oh, poor thing. That suddenly explodes, increasing many thousand of times in brightness. Wow. Okay. So what they're showing here, I guess, is the star. It just starts to die off and it goes, and that's the end of it. Wow. Okay. Most heavy elements are created by nuclear reactions in supernovas and then return to space. What? Most heavy elements are created by nuclear reactions in supernovas and then return to space. Okay. In 1987, this must be what I was thinking of, a supernova was sighted near the Milky Way Galaxy. This supernova provided astronomers with a unique opportunity to test the theories of the structure of stars. 1987. Pretty interesting. You know what? Let's look up. Well, let's look up Milky Way. It's probably right here because this is space, right? Milky Way. There we go. Oh, look, they have a great nebula in Andromeda, the most distant object in space visible to the naked eye. This book is old. I don't know if they found other things by now, but Milky Way, the galaxy to which our sun belongs. The Milky Way is also the swath of light in the night sky produced by other stars in the galaxy. Yes. So let's look up Galileo because he discovered the Milky Way, right? EFG. And I think maybe when we looked through this before, we saw that, didn't we? Am I misremembering? I think we did a flip through of this. Galileo figure 472. I am so sorry if I just got that song in your head. Because that will haunt you. Here we go. Galileo, an Italian scientist. Oh, here's a painting of him. That's a decent looking guy, right? I mean, you know. An Italian scientist of the late 16th and early 17th centuries. His full name was Galileo Galilei. Galileo proved that objects with different masses fall at the same velocity. And that eyes makes me scratch my head. This is how much of a dingbat I can be sometimes. Like, wait, different objects with different masses. Oh, I see. If they're the same weight, but I don't know. Because a feather and an apple. I'm going to have to study that. I feel really goofy saying that because now you're kind of like going, what? Okay. One of the first persons to use a telescope to examine objects in the sky, he saw the moons of Jupiter, the mountains on the moon of the Earth, and sunspots. Huh. I thought they said he did he found the Milky Way. What is this? Authorities of the Roman Catholic Church forced Galileo to renounce his belief in the model of the solar system proposed by Nicholas Copernicus. Galileo had to assert that the Earth stands still with the sun revolving around it. A famous legend holds that Galileo, after making this public declaration about the motionless Earth, muttered, "Nevertheless, it does move." Didn't they put him to death for that? Or maybe I have that wrong. We're going to have to do one on him because that guy's crazy smart. Okay, that didn't, maybe he didn't, I know he did. I know I saw that somewhere when I was looking it up. What else? What else could we look at? What if we look at the encyclopedia? I don't know if this will have anything. Okay. Milky Way. This is weird. Isn't it weird how things like I just saw this Meniere's disease. I feel like just lately I've seen a couple people saying they have that. Maybe it's my age group. What am I looking up? Milky Way. We're getting close, you guys. Man, you better know. It's right here. It's right here. It's right here. It's right here. Well, it has to be here. I'm just not seeing it. There it is. Milky Way. A faint band of light visible on clear, dark nights, encircling the sky along the line of the galactic equator. It is the combined light of an enormous number of stars in places obscured by clouds of interstellar gas and dust. It is, in fact, the disk of our galaxy, viewed from the vantage point within it. Yeah, we just happen to have like a cool vantage point. Wait, let's see if they have Galileo, if they say anything. I know when I Googled it, I saw that he, kind of discovered it. Galileo, Italian scientist, he studied falling bodies and disproved Aristotle's view that they fall at different rates according to weight. In 1610, he used one of the first astronomical telescopes to discover sunspots, lunar craters, Jupiter's major satellites, and the phases of Venus. In Sidereus Moncius, 1610, he supported the Copernican view of the universe, with Earth orbiting the sun. This was declared heresy, and in 1633 he was brought before the Inquisition and forced to recant. Wow. Crazy. Okay, well, I'm still confused about the things falling. Oh my God. That's the kind of thing, if I tell my husband, he's going to go, "Linda, come on." But like a feather and a rock? What? Anyway. All right, guys. So that was interesting, right? I know a lot of you already know all that, but, it doesn't matter how many times I think about it, I still will be like so in awe of the fact that like we're this little thing. This is our galaxy. And then there's